Starting with question number 2, children. The question is, write the Pythagorean triplet whose one member is given. One member is given as 6. We have to find the other two numbers. Do you remember what is a Pythagorean triplet? The square of the two numbers should be equal, the sum of the square of two numbers should be equal to the square of the third number. So one member is there. So if we had already discussed this some days before, for any natural number greater than 1, if one number is 2m, the other number is m square plus 1, and the third member is m square minus 1. So here first member is this, that is 2m is equal to 6. From here we get the value of m, that is 3. Okay, now we need to know the other two members. So it will be m square plus 1, that is 3 square plus 1, 9 plus 1 which gives us 10, and m square minus 1, that is 3 square minus 1, 9 minus 1 which gives us 8. So what is the answer? Answer is 6, 8 and 10. Going to the next part. Second one. 14. Again. 2m is equal to 14. Okay. So m is equal to 14 upon 2, which is equal to 7. Now second member is m square plus 1. That is 7 square plus 1. 7 7s are 49 plus 1, which gives us 50. And m square minus 1, that is 7 square minus 1, 49 minus 1 which gives us 48. Then we go to the third one. Children, write this at the side, okay, so that you remember. Third one is 16. 16, that means 2m. The first member is 2m is equal to 16. So m is equal to 16 upon 2, which is equal to 8. Then m square plus 1 will be 8 square plus 1. That is 8 is a 64 plus 1 gives us 65. And m square minus 1, that is 8 square minus 1. 64 minus 1 gives us 63. This completes the third one. Fourth one, 18 is your homework. So this completes the exercise 6.2. We go to the next topic, that is square root. Now what is a square root? We studied the squares. Yes, we studied the squares. That is 2 ka square is 4. Correct? Okay. Now we have also studied the inverse operation. For addition is subtraction. For subtraction is addition. For multiplication is division. For division is multiplication. Similarly, the inverse of the squares is the square root. So how? The square of 2 is 4. The square root of 4 will be 2. Square root of 4 will be 2. Now how to find this? How to get this? You see. We know that 2 square is equal to 4. Now this 2 is a square, this side. Now it will change its side and it becomes the square root. So 2 is equal to root over 4. Now we find the prime factors of 4, that is 2 into 2. Now ये जोड़े में है, कोई एक बाहर आता है. Okay, root के अंदर से कोई एक बाहर आता है. So it is 2. Okay. Now one more thing. Let's take a square. Let's take a square who square into two triangles. Can you see this is a right triangle? Yes, and the side opposite to the right angle is known as the hypotenuse. Any one is known as the base, which is at the bottom, and one is known as the perpendicular. And if we use the Pythagoras theorem, by Pythagoras theorem, p square plus b square, that is perpendicular square plus base square, is always equal to hypotenuse square. Now what is p square? 12 square. What is b square? Again 12 square. What is x square? We don't know. But if we solve this, can we get the value of h? That is the hypotenuse, that is the diagonal? Yes, we can. So let's solve it. 12 12s are 144. 12 12s are 144, which is equal to h square. Now 144 plus 144 is 288. 288 is the value of h square, but we don't want to know h square. We want to know h. How to get this h? If we shift this square this side, है ना, इस square को हम यहाँ ला दे दो, correct? So this square, when it changes its side from LHS to RHS or RHS to LHS, it becomes square root. Okay. So this. Now from here we can find the value of h. How? 288. We can find it out. We can find its prime factors. How to find the prime factors? Do you remember? The division method. So these are the prime factors, leaving 1 because 1 is not a prime number, as we all know. So we write these values. Now I already told you that what comes out, the pair comes out, ना जोड़ा comes out. तो इसका एक 2 बाहर आ जाएगा, इसका एक 2 बाहर आ जाएगा. ये अकेला है तो ये बाहर नहीं आएगा, ये अंदर ही रहेगा. ये बाहर आ जाएगा and root over 2. 2 2s are 4, 4 3s are 12. 12 root 2 is equal to h. That is the diagonal. Okay. So this is the measurement of the diagonal, and this is how we find the square root. Okay. So this is one method to find the square root, and there is one more method to find the square root, is the repeated subtraction method. Repeated subtraction method means we keep subtracting the odd numbers. Now how do we do it? See, like suppose we have to find the square root of 81. We start. What is the first odd number? Then what is the second odd number? Third odd number? Next odd number? Next odd number? 17 is the difference, and next odd number after 15 will be 17. Answer is 0. So if you get a 0, that means this has a square root as 1, 2, 3. We stop and we get 0. Now, how many times have we done the subtraction? 1, 2, 3, 4, 5, 6, 7, 8, 9 times. So the square root of 81 is 9. Okay. Square root of 81 is 9. How? 81 is 9 square. That means 9 9s are 81. Yes. So it can also be written as root over like this. Wait. We know 9 square is equal to 81. Yes. Now this square, when it shifts here, it becomes under root. So under root of 81, square root of 81 can be 9 into 9, which is equal to 8 9 बाहर आता है. Yes. So the square root of 9 is 81 is 9. So what can you say? 81 is the square of 9 and 9 is the square root of 81. So square root and square numbers are connected. One is known as the square of the other and one is known as the square root of the other. Okay, in this, if I write this, will answer come 81? Yes. How? Minus into minus becomes plus. So 9 9s will give us 81. So we can say that 9 or minus 9 are the square roots of 81. Clear? Now there is a try these in page 99 regarding this. So there are two methods to find out the square roots. One is the long method, this one. One is the short method, this one. We have done this method. I showed you how to find out the square root and we found this. The number who doesn't have a pair, जिसका पास जोड़ा नहीं होता है या जिसके पास दोस्त नहीं होता है, वो रूट के अंदर ही रहता है. उसको जेल के अंदर ही रखते हैं, उसको बाहर नहीं निकालते, बाकी सबको जेल से बाहर निकाल देते हैं. Got it? So there are two methods. One is the prime factorization method and one is the long repeated subtraction method. Not long division. Now we will move to the Chinese of page 99. So what is the square root of 121? Obviously 11 एक square root होता है और एक square होता है. 14 square is equal to 196. So what is the square root of 196? It is 14. Think, discuss and write. Minus 1 square is equal to 1. Why? Because minus 1 into minus 1 gives us 1. So is a square root of 1? Yes, it is. Yes, similarly minus 2 square is the square root of 4. And minus 9 square is the square root of minus 9 is the square root of 81. So all three are yes, yes and yes. Okay. So this we have already discussed. Then we have done finding the square root of the repeated subtractions using repeated subtraction, then finding square root with the help of prime factorization. Now there is one more. Try these in page 100. Try these. In page 100, by repeated subtraction of odd numbers starting from 1, find whether the following numbers are perfect squares or not. If the number is a perfect square, then find its square root. Okay. So without using the repeated subtraction method also, if you look at the number, you can make out 121 is yes, because 11 11s are 121 and the square root of 121 is what? 11. Then there is exercise 6.3. So we start with exercise 6.3. The right hand copy. What could be the possible ones digits of the square root of each of the following numbers? So what can be the digit in ones place for the square roots of these numbers? So children, for that you just write this. I'll tell you what. 1 into 1 is equal to 1. 2 2s are 4. 3 3s will give you 9. 4 4s will give you 16. 5 5s will give you 25. 6 6 will give you 36. 7 7s will give you 49. 8 8s will give you 64. Now 9 9s will give you 81. 10 10s will give you 100. Okay. Now wherever there is 1 in the question, that means its units place will be 1. Wherever there is 4, its units place will be 2. Wherever there is 9, units place will be 3. Wherever there is 16, units place will be 4. Similarly, wherever there is 5, units place will be. Wherever there is 5 here, units place also 5. Wherever there is 6, units place will be 6. Wherever in the question there is 9, units place will be 7. Wherever there is 4, units place will be 8. Wherever there is 1, units place will be again 9. Wherever there is 0, units place will be a 0. Okay, so you write this in the at the side of your copy, then you write the question. 9801. What is this? 1. So you check in the question wherever there is 1. 1, 1. So what can be in the units place? 1 and 9. Okay. 1 and 9. Referring to this, units place can be either 1, not both. 1 or 9. Then wherever there is 6. Where is 6? In the question. 6 and 6. So, anywhere else? No. So, what can be the units place? Either 4 or 6. So, you can write 4, comma, you put 4 or 6. Now, check where in the answer, in the product, in the square numbers, wherever there is 1. Here is 1, here is 1. So, 1 and 9. 1, 9. Wherever there is 5, there is 5 only in one place, 5, and that too for 5. So, 5. This completes question number 1. We start with question number 2 now. Question number 2, I'll read the question for you without doing any calculation. Find the numbers which are surely not perfect squares. So, in the beginning of the chapter, we discussed that the numbers who end with 2, 3, 7 and 8 are surely not perfect squares. So we can write this note. Note the numbers which end with 2, 3, let me see, 2, 3, 378 are there, means 378 are there. So directly you can write no, 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 and here it is 1. So yes. Okay. So this completes question number 2. Rest we are going to continue later.